Just like in my previous video, as I am discussing about the plot of the two-dimensional graph, I am discussed that when we drive the two-dimensional graph, then by giving the command plot, we also describe its axis. That it means that x comma y, right? But in this case, I replace the x by t and y replaced by I, which is the resultant wave equations, right? And then but in this case I am want to be plotted the three-dimensional graph, so that's why I basically give the command figure figure, and then I given the command plot in the similar case like two dimension. But the difference is that I written the three means that I want to be inserted or plotted the three-dimensional graph. So when I delivered this three, then I also described its three axes, that in which axis this graph is to be plotted. So I written this t comma I comma ib. As you can see that t is replaced by x, I is replaced by y, and ib is replaced by z. Now let comes to another. When I run this, then the graph is to be plotted into the MATLAB, and this graph is to be shown in my another slide. This is three-dimensional graph. Its first dimension and its second and its third. First dimension is this, second and this third dimension, as you can see it properly in my another slide. Sorry. Okay, in my another slide, as you can see the video which I am to be inserted in order you understand betterly the three-dimensional graph. So this is 3D graph plotting in the MATLAB, and we can draw this graph in the MATLAB by simply giving command of the figure of plot 3 into the editor file. And as you can see that this is a 3D graph plotting device, so that's why it has three dimension. First dimension this, second dimension this, and third dimension this. By simply clicking this icon, we can rotate it into the three dimension. As you can see, this. Now we can easily change its dimension by rotating into the three dimension. In first dimension it looks like that, in second dimension it looks like that, and in third dimension it looks like that. So you can easily rotate into all of the three rotations and simply changing its dimension. Now let comes to another slide. This slide is basically shown that how we drive the two-dimensional graph in the MATLAB, and this is similar like that of the three-dimensional graph that we assign f1, f2, omega 1, omega 2, t, I, comma, I, b, and I. And by simply given plot t, comma, I, and grid on, then you can show the two-dimensional graph in the MATLAB. In another slide, you can show this graph. You have to be shown this graph. This is the two-dimensional graph. As you can see, right? This horizontal and vertical lines which are to be shown in the inside the graph is basically due to we own the grid, so that's why these horizontal and vertical lines are to be shown by them. Okay, this is two-dimensional graph. Now let comes to another slide. Now this is my last slide. Okay, in this slides I am discussing with you the applications of the beat frequency, that how beat frequency is very helpful in our daily life routine. As I discussed in the third slide with you when I delivered you the example of the beat, I am discussing you with that the beat are used in tuning musical instrument, in tuning folks, in musical instrument. We can hear in daily basis the violin, star, guitar sounds, right? And we also hear the nas in the form nas by the help of the musical instrument, right? Because most of the musicians also using the musical instrument by taking the rhythm, right? So in all of these cases the beat frequency application is very helpful. And in next point, I am discussing the sonometer experiments in which beats can be used to adjust the vibrating length between the two bridges. It means that this sonometer experiment is done by many scientists. So by using this experiments, beat can be used to adjust the. It means that there would be imagine that there will be two bridges, and you want to find out the vibrating lengths of these two bridges, right? So with the help of the beats, you can easily find out these vibrating line.